Hello, welcome to Karmada community meeting. Today is November 14th, 2023. The meeting is recorded and will be uploaded to YouTube. So I'm gonna check today's agenda. Hi, Charles will show a demo about the attended resource support in resource model. Yeah, Charles. Hello, Charles. Hi, Charles.
I think he muted. He muted.
I think there's a network problem. I see he joined the meeting with another phone. Yeah, we can hear you. Hello. Hello, Charles.
Hello.
Hello.
Sure. I share the desktop.
Yeah, you can share your screen now.
Okay. Can you see my desktop?
Yes, we can.
Okay. Now I wanted to introduce you Karmada resource model supports extended resource. Let me begin. First is a prerequisites. First I install Karmada. For my latest code, yet is in my personal branch, so I clone my personal Karmada repo, and I install Karmada by look up Karmada. And there is a note. Karmada schedule estimator already supports extended resources. So in order to test the resource model feature sufficiently, I disabled the scheduler estimator. Besides, I installed 3 nodes in member1 cluster. Then I mock extended resource by device plugin. You can refer to this report. This report. And this report, the about report shows a simple way to mock extended resource. It will run as a demo set in member clusters. So we build a Docker image and load it to member clusters first. So you can see I git clone this report and build an image. You can ignore this two lines. Then I can load. I load this image into member1 and member2 cluster. Okay, that's easy. Then I deploy it as demo set in member clusters, and then it will report extended resource naming Karmada.io GPU to kubelet. I do following things. First, you can ignore. It's not important. You can ignore this line. I apply 了demo set 点 YAML，it's just deployment this this report. You can see just deploying the demo set. The detail is not important. You just see after I do these things, I can check the node of member clusters. That's important. This message is important. kubectl context member one get a node. There I get a node. YAML. You will see allocable this line Karmada .io GPU. The value is 3. The value is 3. And the member one cluster has 3 nodes, just like this. Okay.
Yeah.
That.
Sorry. I can understand that since you don't have a machine with GPU, so you have to use the hacked device plugin to simulate the GPU resources, right?
Yes. You're right. Yes. So this step is just MOOC GPU resource. Okay, and you will see member two clusters after my MOOC, and there is a Karmada .io GPU. The value is 5. Okay. After finishing all the prerequisites, you will get the following member clusters. Member one cluster has 3 nodes. Member one cluster has 3 nodes. Each node has 3 GPU resources. And the member two cluster, just 1 node with 5 GPU resources. Member 3, no GPU resource. Okay, then I started the demo. First, you customize the cluster resource modeling for extended resource. You should first edit the cluster object to specify resource models. You can see this field for Karmada .io GPU as follows. By default, the resource models is just like a CPU grade 0. By default, there are CPU and memory. You should add Karmada .io GPU, and within grade 0, the range is 0 to 4, and grade 1, the GPU range is 4 to 8, just like this. And I will calculate. Okay. Is there any problem?
Yeah, I have a question. Like, how do you choose this like min and max? Like this kind of like granularity. Maybe we can just walk through the whole demo and then I can ask a question. Yeah. I just curious, like how do you choose the granularity? The battery is like min is like 0 to 1, the next is like 1 to 2. It's like better than this one, or like?
Yeah, I can try to answer the question. That depend on the GPU resources in your cluster. If all nodes have average GPU resource, so you can have a short grid list. For example, if each node has 10 GPU, and all nodes have 10 GPU, so actually you one grid would be okay. I know. Sorry.
So I think in your resource model, you put a granularity here, just try to resolve the resource fragmentation issue, right? Ideally,
Yes.
if you the more granularity, the better, the better to solve this issue. So maybe we need your suggestion, like how we like construct the resource model for extended resource like GPU, and based on our current cluster setting, like for example, on each node we have four GPU, and then we totally maybe have 100 node. And if that's the case, how could we properly like how could we properly set up this resource model? And then this is this is my question. Like in general for the resource model, because we also have the CPU and the memory.
Yeah, I think it depends on how many GPU is required by uh by a by a replica. For example, each replica requires one CPU, so you might need to have a model include the range of 0 to 1, so that Karmada can count the nodes can count the nodes with the available GPU.
Sorry, I just a few minutes late. So are you trying to figure out how to use Karmada to do the resource matching, like match all the way down to the node level?
So basically, Shaosi support extended resource in Karmada resource model, which is like from our requirement. Now he is giving a demo. So currently, he show how we can configure the extended resource in the cluster resource model. And then I have a question, like how could we configure this resource model properly to avoid the resource fragmentation issue?
Oh, wait, can I take a step back? What is the resource model used by Karmada right now? Let's do the resource aware scheduling.
So basically, that's my understanding. If I'm wrong, like Hongtai can correct me. So in the Karmada scheduler, they didn't catch all the nodes information for all the cluster. Instead, they categorize their node based on their resource model, just like it's too heavy to catch all the node resource information. So based on this resource model, they can categorize those nodes in different grade, like grade 0, grade 1, and then when Karmada do the scheduling, they can, based on those categorize those node those different grades to select the proper node.
Yes.
Yeah.
Yes,
So
exactly. Yeah.
So
right.
The ideally is like, for example, for GPU is only require one. So for us, we don't have a GPU virtualization, and it's always like granularity. The smallest granularity is one. So the ideal case is like the granularity, the grade 0 is like means from 0, max is 1, and the next
what is grade mean in this configuration?
It's just like different category. You can think it's like a category name. It's always from the smallest one is like the range. So for example, so my question is like, for example, if I have for each node I have 4 GPU, and then I have only 5 nodes, and then in this cluster I have total 20 GPU, that is in total. The best way to avoid resource fragmentation is like the range. Like for 0, 1 is mean is 0, maximum is 1, and for 0, 2 mean is 0, mean is 1, max is 2. It's like we are going to have 20 grade. This if we
Oh wait, can I have
categorize.
Ask one more question? Why do you want to group nodes into different grade? Like what does this solve for Karmada?
So basically, in Karmada, in the cache, it doesn't catch all the nodes information. Instead, they categorize the nodes in different grade. In this, based on
so it's
resource
only
model.
cache the grade information for every cluster. So it will have
Yes.
multiple grade, and each grade you
Contains
know
several
how many resource, what's the maximum resource left, what's the minimum resource
Yeah,
left.
and then
Yes.
how many nodes in that grade.
Oh,
So,
okay.
And then, so the
you think the
in
granularity is not enough? That's what you're saying, right? So yeah.
So my question is like, how could we properly choose the granularity, like to construct our resource model to avoid the resource fragmentation based on our cluster setup, right?
I see. Oh, okay. Yeah. Let me just refresh what you told me, because we were just discussing it last week at KubeCon. So we were thinking to have a cross cluster scheduler. So if you just imagine how how we group our cluster together. So we may have something called a tier. Inside a tier, we have multiple cluster, and different cluster have a group of resource. And when a training workload is submitted into our infrastructure, it's submitted into a tier. And the cross-cluster scheduler in front of the tier need to decide if this workload can be submitted into cluster A or cluster 2. But one problem we know is that, especially for GPU workload, in most situations, one physical node only have 4 GPU. Sometimes it only has 2 GPU. And if the user workload say, hey, I want to run a training workload with 10 worker, and each worker, meaning each pod, need 4 GPU. It means that the cross-cluster scheduler need to find 10 physical node, and all of them need to have 4 GPU available. So what it means is that on the cluster level or on the node grade level, you will see that there are 40 GPU available. But if all of them only have like 3 GPU available per node, the workload still cannot be scheduled. That's the fragmentation issue that Yao was mentioned, because if there are a lot of like small workload already occupy part of the GPU for each physical node, and you have a large workload coming, and each pod need to occupy all the GPU on each physical machine, then that workload cannot be scheduled. Does it make sense? Did I explain it clear enough? I guess the question is that with the node grade information, do you think Karmada's cross-cluster scheduler can make basically you need to make a matching decision, right? So can this workload be submitted into this cluster? I think it seems like you don't have enough information to decide if this workload can submit into this cluster, because you don't have information on the node level.
Actually, Karmada have all the information, but Karmada cannot cannot store them for example in etcd. It's too huge for Karmada. No, so we have to.
But I think Kubernetes has I believe Kubernetes has a cached client. Maybe y'all can correct me. I remember Kubernetes has a cached client. The cached client already have all the node information. Yeah, do you remember either in client Go or API machinery? I think y'all looked into it before. There's a cached Kubernetes client. I believe it already have all the node information.
I think it's the XCD for the Karmada control plane itself. So it may not big enough. Like our cluster, so in our case, each cluster only have like less 100 nodes, and we only have 2 cluster to manage that. For example, I think Hongcai means like in the Karmada control plane, they may not in their XCD, they also need to, if they want to catch all the nodes, they need to store those information.
Oh, I see.
Their XCD, they might not have that.
So the way you store node information is as a custom resource. That's how you store it, right? So the information is actually stored in etcd.
Yes.
Oh, I see.
They are public cloud. They may maintain thousands of nodes. It's not.
Yeah, I think that's going to be a problem because etcd is now designed to store very large resource. So basically,
Yes.
the way, if you want to store it in etcd, the more node and the more cluster you need to store, the less scalable it becomes, because etcd is not very good with large object.
Yes.
So
you
about,
maybe you want to reconsider if you want to store this information in etcd or just put it in a cached client.
So maybe we can ask Chaosi to continue the demo. I really want to see like how it works now, and then maybe we can reproduce the similar demo from our side and see if we have any issue. Is that okay? Yeah.
Okay.
Yeah.
Thank
Thank
you.
you so much.
Okay.
Yeah.
Okay. Now let me continue.
Yeah. Yes, please. Thank you
Okay.
so much. Yeah.
Okay. Just now, my network, my desktop network has some problem. Wait for a moment.
Well, it
Okay.
doesn't have to be a real-time demo. I mean, we can go through your doc. I think it's already very good. Yeah.
The zone has disconnected.
Oh, sorry.
We can also, like, this is not a released feature. We can also rethink it a little more.
Just one moment. I reconnect.
Okay.
Yeah.
I'm also, I'm still trying to find the cache client you used before.
That is like the controller cache client. This is more like you cache everything in the memory, but everything should be synced to the XCD.
Oh, no. What I mean is that maybe what's possible is when scheduler do the matching, it should based on something cached in memory, and what's stored in etcd is more like a summary, right? Because etcd is not good at storing a very large component. It can store some kind of summary, but all the node information maybe still should live in the cache, I guess.
Yeah.
I don't know. We can discuss it.
I think even in if we cache all the nodes and post resources in memory, it will be scalability issues.
Yeah,
No.
for sure.
Yeah. So for Karmada, it might manage hundreds clusters, so it can
So so that's going to be a problem. If you have a user, they have a huge cluster, like and several hundred of them, it's going to be a problem for sure. I don't know. Is this like very slow to get all the node information? So for example, in the situation, if you have user with, like, let's say several hundred cluster, maybe can first do a round of like ranking, something like that, and select the most possible cluster that can schedule this workload, and then get all the node information from the most possible cluster. Do like 2-layer matching.
No, I don't think it'll work because because the scheduler should make the schedule decisions as soon as possible. At each schedule maybe the scheduler maybe select more than one cluster each time, you know.
Yeah.
So scheduler might be when select a cluster, scheduler might need to know all the resource informations from all cluster.
Yeah.
This meeting is being recorded.
Yeah, I don't have a good way.
Is that possible, like for Karmada provide two resource model? One is like you have those categorized the resource model. The other is like you allow user to cache all the node information. Is that too much work? Like, because we are kind of like, you can think we're like private cloud. We don't have that our scale cannot compare with the public cloud, right? So the total cluster may be less than 200. It's okay for us to cache all the nodes information in the federation layer, like in the Karmada layer. So is that possible to tweak a little bit for the cache, for the internal cache? Like for a small cluster like us, enable user to cache all the nodes.
I have another question. If we don't cache all the nodes, then it will only, so Karmada will only find out when the workload is actually scheduled in the cluster. That's when the cluster itself will reject it, right? The cluster itself will say we don't have enough resource to schedule this workload. And it will reject it. And what's the behavior from Karmada side if the cluster itself rejected?
So the binding, they have the customer resource called policy binding or something binding, and then they will reflect it in that. If I remember correctly, it will be reflected in that part. You will see the job is not like
So, hello, Chaozu, are you back?
Okay. Yes.
Oh yeah,
let me
sure.
let me continue.
Sorry, interrupt you.
Okay. Let me say. This is member one. Member one has 3 nodes. Each node has 3 GPU. So there are all is 9 GPU, and we specify 1 to 4 GPU as grade 0. So there are grade 0 has 3 count nodes. The 3 means we have 3 nodes meet the GPU range from 0 to 4. Okay. Similarly, member 2. You can see there are just one node. This node has 5 GPU. So 5 is within 4 to 8 this range. So we calculated
4 to 8 means you have 4 to 8 GPU available on those machines, right? That's what 4 to 8 means.
This means this node GPU greater than 4, less than 8. So
this is available GPU. This is GPU that's still allocable on each node.
Yes.
Okay.
Yes. Okay. That grade 1 has 1 count. Okay. Then we write a deployment. You can say this is a deployment. It needs GPU, 5 GPU. It needs 5 GPU. Now we want to distribute it to member 1 or member 2. Member 1 or member 2. Although member one has 9 GPU. Although they have 1 GPU, but each node, the total has 3 nodes. Each node's GPU is less than 3. So we can't find any node from member one. You know what I mean?
Yeah.
Well, member two, although it has just 1 node, but its GPU meets the requirement. So we expect distribute this deployment to member two. Then we let us see the result. We applied this this YAML. Then check the result. You can see the deployment is ready, and it has distributed to member 2. The replicate is 1, and is healthy. And from the scheduler log, you can see we calculated cluster member 1. No replicates available. Actually, no nodes available for cluster resource. According to cluster resource models, no nodes meet the requirement, while member 2 can allocate 1 replicates. So we assign this deployment to cluster 2.
Actually, I think maybe their approach will work. Yeah, I think their approach will work. It will work. It's just like not like work one. It will at least reject impossible scenario, right? Because you can match against. Yeah. I think it will work.
So basically, in our case, so we can. So for example, our node have 8 GPU. Let me think how could we categorize it properly? It's just like we have 8 grids.
So the range is something we can configure, right?
Can we make the range to only 1? So like the grade 1 is 0 to 1 GPU.
Yeah, the next
and the grade 2 is 1 to 2.
1 to 2, yeah. And then
we have 8 grades
for
yeah.
Yeah, that will solve the GPU things because granularity is always 1. And then
I just want to make sure if the min or max is inclusive. So if we set the min to 0 and max to 1, no. If we set min to 1 and max to 2, so let's say our grade 0 has 0 to 1 and grade 1 has 1 to 2. Then if requests come in, they request for 1 GPU, is the two grade node available or just 1?
It's left open, right close, right? The range is.
Yes, I'm checking the API. It's recorded in the API comments. I think.
My side.
Yeah, I feel if we can configure the grade ourselves, it should work.
Yeah.
So we just configure to the most granular level. That will be fine. I think for people who have 100 cluster, they may want a less granular configuration.
Yeah.
No,
so what's the maximum number we have on node?
Each node can at most have 4 GPU. I think I actually don't think other company can. I don't know, at least in over setup, it's like 4 GPU per node at most.
Okay.
Yeah. Yeah. So this is for the GPU things, and I have a question for the CPU and the memory.
Oh, actually, in the future there may be 8 because they're different. They are designed to allow 8 GPU. So eventually, maybe there will be 8 GPU per node. But as long as this part is configurable, I think that's fine.
Okay.
Yeah.
If you
So-
if you no need
Oh.
to separate this range to detail, you can just specify just 3 or 4 grid. It's okay too. It's
Yeah, but I think I need to think about the CPU and memory offline. Maybe we just categorize the total the node resource based on the GPU.
Yeah.
portion.
One more thing is in the resource model, we can add as many extended resource as possible, right? So here you have Karmada.io/GPU.
Yes.
We
Yes.
have we may have more extended resource. So
Yes.
that's
Yes.
configurable. Okay.
Yes.
Yeah. Actually, Karmada don't care the resource name here. You can specific any name you want, like Bloomberg GPU. That's okay.
Okay.
Yes.
So
Oh,
so in your grid, we must specify the CPU and memory. What if we left the CPU and memory to blank? So what if we
To blank? That means Karmada will build the model without the CPU and memory. If in that case, if your workload still requires CPU and memory, so the scheduler may be think there's no available nodes for the application.
Okay.
Charles, do you have a link to this documentation you are sharing? I think Leon is asking. Leon is also from Metin. He's asking if you have a link to the doc.
Yes.
This doc link is in the meeting notes. Yeah.
Yes.
Oh, cool. Thanks.
Oh, are you?
Can you also post meeting note? I think I don't have.
I don't have that.
Is that possible?
I can share the meeting notes link to the chat.
Oh, actually, I found it. Thank you.
Is that possible to create a pre-release for this support, and then we can test ourselves?
I think we are, since we are going to have the next release at by the end of this month, so we can try to include this feature in this release. But if we can finish it before if we can finish it earlier, so no problem, we can have a pre-release. So
that would be great. And then for the next, maybe we still have another requirement for the scheduling based on priority, and also do preemption in the Karmada control layer. Do you think if that is possible?
I think we can
or we can write out our requirements, and then we can discuss in the next.
Maybe it's better. So maybe it's better that we put together a super high level design that we were discussing last week, and then we can see how Karmada best fitting into the design. There's one more question I do have, is that when we deploy the Karmada scheduler, it's going to be across multiple cluster, right? But Karmada schedule itself also need to be deployed into a Kubernetes cluster. So like normally, how do people do that deployment? Like if that Kubernetes cluster have an issue or whatever, how does it fail over?
Actually, Karmada scheduler can run out of a cluster, but usually a Karmada user will deploy Karmada in a cluster, like deploy Karmada in a small cluster, and so let the cluster as the Karmada control plane.
Our question is, if that cluster is done, what's the resonance, like the
Yeah, like, so for example, it's easy for us to create a separate Kubernetes cluster and deploy Karmada there. But what if that separate cluster have issue, like API server or etcd have issue, and that cause Karmada schedule doesn't work? What would be the best way to fail over?
Do you mean you are you are
just
considering the yeah, go ahead.
No, just very basic example. If something's wrong with the etcd, right, that explode the etcd in the cluster where I deploy Karmada, then I'm just thinking what's the best way to deploy Karmada so it doesn't become the single point of failure.
Yeah, I think we are trying to provide some practice to build a high available Karmada. So
like an HA mode.
Yes, exactly. Yeah.
But your HA mode will need multiple cluster to achieve, right? So like, sounds like you need like a standby cluster.
Not sure yet, but we have some practice from our users. They are running multiple Karmada instance, So even in case one Karmada instance down, so the other instance can take over the work.
Okay.
Basically, the your etcd or the storage is stretched, right? They are highly available. And there
must be some challenge here. So
yeah, stretch cluster, we can handle that. So yeah, we know how to deploy a stretch cluster. The main issue is that even though we deploy a stretch cluster, that stretch cluster still can fail. So
no, I think last time from Kevin is more like you have Karmada running on two cluster, like in our case. So but they share the same etcd or backend.
Right.
Yeah. I think we are using Kime plus Postgres.
So as long as the etcd is consistent, like highly available, we can easily switch. So if say one cluster is down, the other one just like start scheduling and catch up.
So we still need two cluster per tier, right? So one is the active cluster, the other one is the standby.
Yeah, something like that.
Yeah.
If we do it ourselves.
Yeah.
Sorry, I have a question, Yao. In this demo, Charles simulated the GPU by device plugin, and then the GPU resource will be reported to the node.
Yeah.
Is that the case?
We have a similar setting. We use the NVIDIA GPU device plugin, and then data report all the allocation response, everything to kubelet. And also the node capacity will be populated with that resource.
Yeah,
exactly the same. Yeah.
I think we can discuss your requirements one by one. So for now,
we first want to POC this one. I really appreciate your help, like to support extended resource. If we can like POC that as soon as possible, or do you have a branch? Maybe we can.
Yeah, if you have a master branch, we can just deploy the master.
or we can build we can build locally. It's just like our POC. We want to see like how it handles the GPU. things.
Yeah, if it doesn't like night review or something, and try.
Thank you for the feedback. We can try our best to release this feature. Okay.
Yeah.
I can sync the progress with you as soon as possible.
Sure. Thank you.
Okay.
Yeah, and then go ahead. So could we put our discussion topic in the agenda for our next meetup? We have another requirement for the preemption in the federation level.
Sure. Go ahead.
Yeah.
At the meantime, you can open an issue too, so it makes things easier to track this.
Yeah, we can also contribute the priority part, I think. So if we put together a proposal, we can.
That sounds great.
Sounds great.
Yeah.
Yeah, so basically we were at KubeCon, so there were a lot of in-cluster scheduling which already support priority queue preemption, but because we are trying to move to the cross-cluster thing, but we haven't really found any cross-cluster scheduler to support these features. And I think it's more complicated because it's a global queue, manage multiple cluster, and we need to figure out how to do priority and preemption in that global queue. So that will require some time to design it, I believe. But yeah. And one more thing is I actually don't know how Unicorn do this. It's like how they persist their queue. So I'd imagine if, for example, if somehow for some reason the Unicorn scheduler died in the cluster, how does it recover the queue back?
Recover the queue. So actually scheduler don't recover queue. When the scheduler start up, it will build the queue from scratch.
It's not. I think it's not a job queue. It's a resource queue. It's not like you.
It's a job queue, right?
So the job queue is inside the scheduler itself. It's
yes, the scheduler actually essentially is a controller. Yeah.
You mean Karmada scheduler is essentially a controller, right? And you mean
yes,
Karmada
actually,
Kube controller still is a controller.
It's a controller. The only difference is the queue. It's scheduled using a priority queue, but other controller using just work queue rate limit. Like it's.
Yeah. I see what you mean. You mean the controller itself has a work queue, but that's a queue for Kubernetes event, right? For the create update event. But I think we're talking about another queue. Like if user keeps submitting workload and some of them cannot be scheduled yet, those workload need to be put in a queue somewhere. Yeah, but anyway, we have some time to think about it later. We can also take a look how Unicorn implement their queuing and priority and see if we can somehow figure out a way to put that logic into Karmada.
Yeah, I think you can feel free to open an issue to track anything. For example, your question, your feature, or your concerning things. Yeah.
Okay, sounds good.
So,
right.
Okay, thank you. The meeting time is run out, so I'm gonna say see you next time.
Yeah, have a good night.
Yeah,
Bye.
Thank you.
Thank you. Oh, but by the way, if you want
you.
to reschedule the meeting time, it's totally okay for us in New York, because I know it's already like midnight.
Oh, it's midnight, right?
Yeah.
Okay, thank you.
we can do it in the morning. All right. Bye bye. Have a good night.
Okay, bye.
Yeah.
Thank you.
Bye.
Bye bye.
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 Bye.